Okay, welcome to another one of our GCSE Geography Revision videos. Today we're going to be looking at coasts, trying to cover a fair bit of theory in one video. Okay, so we'll start with some very basic principles about what we need to know about coasts. Okay, three things. Hopefully you can see the pictures, they might be a little bit unclear, but the idea that the coast is basically a giant conveyor belt. If we think of it as a giant conveyor belt, in that first of all material is worn away, so worn away from the cliffs either by erosion or weathering. It's then transported down the coast, so the waves move that material through transportation down the coast, and then finally our material is deposited, usually deposited to form beaches. Okay, so we've got four key processes that then branch out as different things. So we've got erosion and weathering, that breaks the material away from the cliff. Then we've got transportation, moves it, and deposition is where material is deposited. Okay, so if we think of like likely exam questions, now again you might not be able to see this, unfortunately we might be a bit too far away today, but we can break our erosion process and our weathering process into four examples of each, okay? Or, to put that another way, 4 examples of erosion, 3 of weathering, and 1 wetting and drying that kind of falls into both, right? So, usual standard questions are, give 2 examples of marine erosion. Marine erosion because it's done by the sea, okay? Think sea, think marine, marine erosion. So we usually have abrasion or corrosion. Abrasion or corrosion. You would get a mark for saying either one of those, and that's basically where the waves, with their energy, are able to hurl material, throw material directly at the cliff, and that basically causes bits of the cliff to break off, okay? A little bit like if you stood doing exactly the same thing, picked up a load of pebbles, hurled them as hard as you could at the cliff, you would probably cause little bits to break off. So abrasion and corrosion, wave energy, allows material to be thrown at the cliff, and that's what breaks sections of it off. Hydraulic pressure or hydraulic action is your next one, and that is basically where when the waves hit the cliff, small pockets of air get into the little cracks and the little fissures, that's a good word to use, F-I-S-S-U-R, they get into those little cracks in the cliff, and because there's so many pockets of air, those pockets of air explode, and the sheer force of all those pockets of air exploding at once widens that crack further. So hydraulic action, pockets of air in the wave get into the cracks, they explode, force the crack wider. Attrition is the only thing not to do with actually wearing the cliff away. But evidence of attrition is when we get our round pebbles sat on our beaches, okay? Attrition is where our angular rocks crash into each other within the currents of the sea, and they basically shrink in size, but they also become rounder and smoother because of how they bang together in the ocean current. And then finally you've got solution. And solution is to do with the chemical reaction between chemical elements in the rock and then your salt water in the sea. And usually, when the seawater dries off the cliff, it leaves behind little salt crystals, and they grow. And as they grow, they basically cause the rock to break apart. So, 4 things to make sure you're aware of for marine erosion. Abrasion and corrosion, hydraulic action, attrition, and solution. In terms of weathering, alright, we've got chemical weathering, which we can also call corrosion. That's usually to do with acid in the rainwater reacting with chemical elements in the cliff. A good example is limestone, okay? Limestone is always quite seriously affected by acid rain. We have biological weathering, which is caused through burrowing animals, sort of burrowing down, creating their habitats underground, into the soil and into the rock, or vegetation, tree roots, plant roots, basically as they grow and they expand down into the soil, they go into the rock and they cause the rock to break apart. So that's biological. And finally, freeze thaw, one that everyone always seems to remember. Your water gets into a crack in the rock, it freezes. As the water freezes, it expands, okay? That water then melts, but that crack has now been made wider by water expanding when it was frozen. So the next time more water fills into the crack, that freezes, and then obviously, because it's more water in, it expands further, and the process continues, okay? So each time the water freezes, the crack is getting wider and wider because that water freezing is expanding and causing the crack to widen. And then finally, wetting and drying. The simple process of the rock gets wet and then it dries, okay? And often it will contract when it's wet and then expand again when it's dry, and that constant sort of that motion causes the rock to sort of break apart, okay, like in little layers. The easy ones to remember though are the 4 erosion and the 3 weathering processes. Alright, so again, might be tricky to see this picture, but know, if you're given a picture, know what to look for to say, I know that coastal processes have occurred. I know that like erosion has happened, okay? So in this picture, I've got a picture of a cliff line here, and then I've got a pebbled beach here. So straight away, I've got a piece of evidence of erosion because I know that attrition has happened. If I've got pebbles on my beach, I know that in the currents, off here in the sea, I know that those rocks have been crashing into each other, banging around, smoothing down and becoming pebbles, okay? I've got evidence of sort of soil and earth here, slumping down the cliff, okay? Slumping, a process where your weaker rock gets too heavy, something like clay, for example, or soil gets very heavy as it fills up with rain and literally slumps down the cliff. So I've got evidence, I suppose, of weathering happening, not necessarily erosion. I've got discoloration in the cliff, okay? The cliff is like a darker shade of white. That could be to do with solution. I haven't got any landforms, but going out here, as we'll come on to the next slide, I have got a headland sticking out, suggesting that this bit of the picture here is more part of a bay, okay? I can also argue, obviously, and we'll get onto it in another video, that things like longshore drift have been happening here if I've got material deposited. So, what do we need to know about cliff erosion? Again, if you can't see the diagram, look online, go on the VLE, other GCSE sites like Bite Size, for example. So when your cliff erodes, basically what's happening is it will be eroded from the bottom, okay? The sea will attack the base of the cliff, and over time it will wear almost like a little dent in the base of the cliff. That's called a wave cut notch, okay? And that wave cut notch will then go back further and further, and it will erode faster than the top of the cliff. A process known as undercutting, very similar to what happens with a waterfall, okay? So we've got a wave cut notch forms, and what happens over time is that our overhang, okay, basically that is weakened by weathering at the top of it, and then it's got no support underneath, so eventually it collapses. And then that collapsed material, that gets taken away by waves, by sort of waves taking material back under backwash. And then that creates this wave cut platform, basically, okay? So you've got the idea of wave cut notch, that's the base of the cliff being eroded, the overhang then collapses, and then finally that then obviously moves further back, creating this wave cut platform. Next thing on our list really of landforms, if landforms are our wave cut notch and our wave cut platform, then we've also got headlands and bays. Headlands and bays form usually where you've got bands of different rocks. So you've got hard rock and then you've got soft rock. Or if you've got the same rock, maybe the sea has been able to target a weakness in that rock, okay? But where you've got hard and soft rock, our hard rock is more resistant, it's less prone to erosion, okay? Something like granite, for example, would make a good hard rock coastline, okay? Our soft rock, often something like clay or sandstone or something like that, is much less resistant, okay? It's a much softer rock, it erodes more quickly, and therefore what happens is we end up with the formation of our headlands, which are our hard rock outcrops, sort of sticking out about here, and then our soft rock begins to form a bay because that has moved further back than our headlands on either side, okay? So that then leaves a headland, which as we'll see in our final image, which can be attacked by the sea. So what you've got to imagine is you've got a bay on this side and you've got a bay on the other side, okay? Our cliff always has lines of weakness, and those lines of weakness will be attacked by process of erosion, so by your abrasion, by your hydraulic pressure, and those lines of weakness will be widened over time. And as they widen over time, they usually converge together, you know, a number of them join up, and eventually we get a collapsing of that section of the cliff into a cave, okay? So we go from lines of weakness into a cave. Because the sea has been attacked on both sides by the headland, that cave is then worn through to create an arch, okay? So the next stage of the process is an arch. What you then have is undercutting occurs at either base of the arch there, and weathering occurs at the top, and therefore the arch is gradually weakened until it collapses, and so then you're left with a stack, Okay, and the base of the stack, similar to our wave cut notch and our wave cut platform, the base of the stack is attacked by erosion. It's undercutted, the base of it wears away quicker than the top, and so without that support, that stack then collapses into the sea, and that leaves us with a stump. Okay, and obviously that is how a headland erodes over time. So very good for a question about a landform that you have studied where natural processes have changed it over time. Place detail would be Flamborough Head. We visited Flamborough Head as part of our control assessment. Okay, there you have got headlands where erosion and weathering, your natural processes have changed over time. Make sure you talk about that sequence of events from going from a line of weakness all the way through to a stump, and make sure that you name check the rock type, for example, it's chalk at Flamborough Head, and make sure you name check your types of erosion. Attrition, hydraulic action, abrasion, and then weathering. A good example of weathering at Flamborough is that biological weathering. Lots of seabirds there, burrowing into the rock, forming their habitats, and obviously weakening it. Okay? Lovely.